Well, I've received this instrument from the brand FNIRSI for review, and I'm really excited about it. It's a tablet that packs 4 instruments into one, a real signal analysis lab. There's an oscilloscope with 2 channels, 350 MHz of bandwidth, and a 1 GHz sampling rate. It's all fully digital. The only analog thing it has is the power button. Everything else is on the touchscreen. In the semi-rigid case we're used to from FNIRSI, with its characteristic colors, black and light blue, it comes with the charger and its USB cable, the cable for the signal generator, the 2 350 MHz probes with the screwdriver and identification rings. The manual in several languages, including Spanish. Everything is very nicely presented. We take out the tablet, and on the back it has a stand, so it can be positioned at an angle, standing up like this at an angle. The battery, according to the manual, has a battery life of 4 to 6 hours. And, well, I couldn't really test that very well because I've had it on for quite a while, but I didn't really keep track of the time. Now, something really good about this type of oscilloscope is that since it's battery powered, there's no risk of a short circuit on the AC mains, like in most benchtop oscilloscopes, which have the ground clip connected to the outlet's ground. And depending on where it's connected, well, it can cause a direct short circuit on the AC mains, right? When we turn it on, a fan starts running. That's why it's better to have it in this position at an angle and not flat against the workbench horizontally. The fan's a bit noisy. When we connect the charger, some red lights turn on here on the side. Take a look. Let's take a look at the oscilloscope. As I told you, all the controls are touch-based. In the system menu, we can, well, save the startup configuration, and here we have the perform calibration. Connect to the PC using the USB cable, USB, and also set up the automatic shutdown. In the language settings, it doesn't include Spanish, no comments. It's in the manual, but not here. Reset to factory settings and format the memory disk. Function menu. Well, XY mode to see the lysojuice figure, using both channels. Switch to frequency response analysis mode, which we will see later on. And spectrum analyzer mode. Like I said, this is a real laboratory. I've already mentioned 3 functions: oscilloscope, frequency response analyzer, and spectrum analyzer. There's still one more that we'll see soon. In the measurement menu, we adjust the parameters of the channels we're interested in viewing. They are graphed at the bottom. The peak-to-peak voltage, average, maximum, minimum frequency, well, for both channels separately. Next, we have the browser menu, where we see the saved images, the X and Y cursors. Image capture button. Zoom function that allows you to enlarge sections of a signal. On the right side, we have the button to stop the live signal view. And we have the auto adjustment. A button to center the signal in the middle of the screen. And increase or decrease the amplitude of the signal. The bottom bar has 2 lines. The upper one with the parameters of the channels we selected in the measurements. And the second one, well, it has the activation of channel 1 and 2 with their respective settings, attenuation, and sliding. And that's how it's going to be, and like that. Fourier transform, and the bandwidth to limit the delivered bandwidth, right? On the other hand, if we limit it, we have greater filtering of the noise, improvement in accuracy, and it prevents aliasing, which are ghost signals, right? But of course, everything comes at a price with the resulting loss of bandwidth, right? Here, yes, we keep changing. We keep changing. It's at 350, and when we change it, it goes down. All right, next is the control for the horizontal grid. We can increase or decrease it as we like. The trigger control. And, well, here we come to the last function that we hadn't mentioned yet. The signal generator. This one has 15 different waveforms. Frequency settings up to 50 mHz in sine wave, 10 mHz in square wave, and less in the other waveforms. It also allows you to adjust the amplitude up to 60.5 volts and the duty cycle. Finally, the movement button adjusts the movement of the on-screen commands to slow or fast. Let's do some tests with the oscilloscope looking at an HF signal. I'm going to set it to AM. I'm loosely coupling it here directly to the HF antenna cable. And I set it to low power in AM. There's the carrier, and now I'm doing the audio modulation. Typical shape, right? The typical M shape. Now let's look at the spectrum analyzer with the same signal. You can see the fundamental at 7,150, which is where the equipment is transmitting. And here, it also has other features. Check out the waterfall display. It also has another mode, which is a 3D visualization. Very, very nice, isn't it? Very eye-catching. Another eye-catching thing, the oscilloscope goes up to 350 MHz, as I told you. However, the spectrum analyzer goes up to 500 MHz. Look, it goes up to 500, right? So I'm going to test it with a 440 megahertz MH signal from here, from the Vive Vanda, from the TM732, and we'll test it. Yeah, look, there it is. There's the signal. Very interesting. This is at 440 MHz, right? Very interesting. All right, we still need to test the frequency response analyzer for Bode plots and filter analysis. I'm going to build a filter with a capacitor and a resistor, a high-pass filter. For this test, the signal generator and both channels of the oscilloscope are used. First, all the probes are shorted together and calibrated. And then the generator and the channel 1 input go to the free end of the capacitor, and channel 2 goes to the junction of the capacitor with the resistor, and all the grounds go to the common point, to the end of the resistor. We set the frequency range that we are going to sweep between 1 kHz and 10 kHz. According to the theoretical calculation, this filter with a 15,000 ohm resistor and 4.7 nano should be around 2,260, right? At the cutoff. Well, let's look at the Bode diagram. Here we can see it. The curve formed nicely. We lower the cursor down to -3 dB, which would be half the power, and that gives us the cutoff frequency, right? And as we can see here, here is the frequency. It's a value that's quite close to the calculated theoretical value. We would have to check the exact values of resistance and capacitance because, well, they definitely have some tolerance. It could be a little higher or a little lower, right? Well, I really like this instrument. Of course, I think the value it has, the price it has, is the one that, well, normally you would only pay for an oscilloscope with these features. But here we have, as added value, the function generator, the spectrum analyzer, which, although limited, and the frequency response analyzer, all included, right? Well, down below, I'll leave you the purchase link on AliExpress, and also check it out on Mercado Libre. The price, according to what a colleague told me, is not far from the price they list on AliExpress. And, well, if you don't want to deal with complications or ordering from abroad, you can just do it through Mercado Libre, right? Thank you so much for watching the video. I hope you liked it. Please give it a like, subscribe, and see you next time, God willing.